Hi, this is the KBS development interview. We are going to, this is a knowledge elicitation technique, and our expert here is Hugo Morales. He's an expert in mechatronics, and he is going to help us design a system that will help choose the motor for a robot actuator. So he'll be leading the conversation, and he'll tell us how one should go about choosing a good motor. And Hugo, hi, this is our team, Nitin, Karthik, and myself, Abhi.
Hello.
So I guess we can start at the beginning. So what should be the first concern for anyone who has a robot actuator and is choosing a motor? What should be the how should they start?
First, well, you need to choose what kind of motor are you using. The first choice is between AC motors and DC motors,
Okay.
which usually the choice is DC motors, I think, most of the time.
Okay.
And then it comes about, I think, the power the motor.
But so what is the difference between an AC motor and DC? We know that it's a different type of current, but
Yeah.
how do you choose that? Okay, these are all AC, and is there a battery type or something like that?
Yeah, it comes in the type of energy. AC it comes like usually three phases.
Okay.
It's the phases, three different currents at the time.
Okay.
While DC is just one phase and direct. AC is like a sine wave current,
Okay.
while DC is just a constant value.
Okay.
But AC motors are usually used in industry because they are like high power motors, and for constant velocities it's a good choice.
Okay.
It requires less maintenance.
Okay.
But I think for robotics is DC motors usually chosen.
Okay. So once you were saying that once you decide that you go on to the power source.
Yeah.
So how is that? I mean, what are the classifications in power source and?
Well, motors for robots are usually not that high power consumption, but you need to take into account how much energy you're going to require. What are you moving? Maybe a small arm, some small different.
Okay.
Kind of functions.
Is there a range for the expected power input? Do you have a sense of maybe a few volts to?
No, sorry. I think I can't give you precise numbers.
Okay. What is it measured in? The units are volts?
Watts.
Watts.
For power.
Power watts.
Yeah.
Okay. Yeah. Power is measured in watts. And when you consider the power source, do you also think about the output? How much you want to output, and
Yeah, it's
because the output is in speed and torque. Right?
Yeah. So there is this conversion factor in the motor where it relates the current to the torque.
Okay.
And the voltage to the speed. So
Okay.
yeah, it's directly related the incoming power to the output power,
Okay.
which is usually specified by the motor.
Okay. So the conversion factor is a specific number for each.
Yeah, it's a constant which depends on the motor.
Okay. Conversion factor. Okay. Then. So I think after the power and the type of current and all that, we can move into some of the specifications of the motor.
Okay.
What is important parameter to gauge the life of a motor, like longevity, how long it functions, like
Okay.
if you use it frequently.
Yeah, of course. How frequently are you going to use it? Because it requires maintenance, of course, and it's also important the environment.
Okay.
Where are you using this motor?
Okay.
That are two important factors.
Okay. So in environment, do you take temperature or?
Yeah, temperature, which
Okay.
there is a range for
There is a
safe,
range for.
safe operation.
Okay.
It has to be respected.
Okay.
But also if there is dust or the conditions of the environment,
Right.
you're using it.
Yeah, they have something called ingress rating, right? Ingress protection.
There is this.
What is that?
there is this value, two numbers value, which the first one is related to how the motor can stand to solid contamination dust, for example.
Okay.
And the second is for liquids. So if it's like, for example, outside and it's going to rain, or how we protect this for this.
Okay. So based on those two numbers, we decide how good it is in protecting.
Yeah, in considering the application you're taking.
Okay. So this is to do with the casing of the motor.
Yeah, how isolated it is, for example.
Okay. And then does the noise level matter for a robot actuator motor?
Yeah, you mean the noise and
Noise that the motor
current, or
produces.
okay. Yeah,
Okay,
yeah.
I meant the sound.
Well, yeah, that depends on the users.
Okay.
But I think for motor, for robot actuators, it's not a big importance, the noise.
Okay.
Because it's not a big, like a giant motor.
Which is because the motor itself is small, there's no.
Yeah, I mean it's going to be noise, but nothing that could be harmful to humans.
Okay.
Yeah.
So then we also wanted to know, are there any size and weight restrictions? So do you decide based on, of course you decide based on the application, but do you have a range for size and weight? Do you know like commonly used?
No,
Or you can, if you can tell us which motor is usually lighter or smaller.
I don't know, because it directly depends on the application, how much power do you need, if you're going to move a big robot part, or just, for example, one finger. It depends, the motor could be like tiny, or could be, I don't know, this size, probably.
Okay.
Yeah.
So, then there is something called the duty cycle load, right? For each motor, it also in performance.
Yeah.
So how do you determine the different, like how do you compare the motors? How do you have a number?
Well, duty cycle is usually in control.
Okay.
The control of the motor is usually 50%.
Okay.
So it's like 50% and then the negative part. But I think that it's usually 50%.
Okay. Then what are the components that affect the life? Like we have brushes and we have controller, we have the commutator, and those kind of things. So
well, in DC motors the main problem is the brushes,
which
is like this to take DC and turn it into the rotation in these pieces which are in constant friction. So that is the main problem with DC motors, that you need to replace them every certain time, and that is, of course, you have to stop the process and everything to replace it.
So that's why you say that brushless DC is more important.
Yeah, it's a good option without brushes, so this is electronically commutated. But the controller, of course, is much more complicated than regular DC, which is just the brushes.
Yeah. So there are types of brushless DC motor as well, right? So
it depends more in the control which is going to be used.
Which type of controller?
Yeah, the wider user is PWM, pulse width modulation.
Sorry?
Is PWM, pulse width modulation.
Oh, pulse width modulation.
Yeah, pulse.
PWM. So that will tell us what type of BLDC motor you require.
Yeah, it depends on the control.
And is there a limit on the maximum allowable current, or how much current you can? Normally, are the motors like able to take any amount of current?
So for safe operations, the motor also has its specifications. And as I told you, the current is related to the torque. So there is one limit to the current. So if you go